Hello everyone, Heather here. Today I'm going to be starting a small series on the Intersection Observer API. These videos are going to be rolling out over the next couple of weeks, so if you want to be notified of updates, make sure you subscribe or head on over to my website and sign up for my newsletter. And I will link that in the description below. It's no secret that modern websites rely pretty heavily on scroll animations. Scrolling can trigger lazy loading of images and data, initiate animations, support infinite loading of content, and so much more. Unfortunately, these scroll events are both unreliable and resource intensive. This means they can cause issues in implementation and often result in pretty poor browser performance, as you may have seen with some sluggishness on scrolling modern sites. The Intersection Observer API was created as a solution to these problems and a new way to handle scroll events. Simply put, the API gives users a way to observe a specific element and monitor changes in the element's intersection with another element, or the browser viewport. What exactly is the problem with the current implementation of scroll events? Well, consider a typical site these days. There are a lot of scroll events going on. The ads on the site load when the user scrolls to them, new content loads when the bottom of the page is reached, elements animate on from time to time, and images are lazily loaded as needed. These scroll events rely upon countless loops calling a ton of browser and resource-intensive methods, like getting the bounding box information for all of the elements to see if they've intersected or not, in order to trigger events at the appropriate time. When these methods run, it's all on the main thread, which means an issue with one causes a problem with everything. The Intersection Observer API passes off the handling of these events to the browser itself. The browser can manage all of these events more effectively and optimize for performance in that particular situation. One really important caveat here is noting the current level of browser support. While Chrome, Edge, and Firefox have implemented the API, Safari is the missing player. That's a pretty big deal, but they're actively working on adding support, so it's still not a bad time to start getting familiar with the API. Until Safari adds support, and for older browsers, looking at you Internet Explorer, the polyfill is pretty sufficient. I'll cover that towards the end of the video. For now though, let's start diving in. To fully understand why the Intersection Observer API is so much better for performance, we're going to start with the basics. A few key terms are used to define any instance of an intersection observer. The root is the element which waits for an object to intersect it. By default, this is the browser viewport. The root element is the basis of a single intersection observer, but this observer can monitor many different targets. The target may also be any valid element, and the observer fires a callback function when any target intersects with the root element. As far as the code is concerned, setting up a simple intersection observer is pretty straightforward. So the first thing we need to do is actually call the intersection observer constructor. So this constructor accepts two arguments. It accepts a callback function that's executed when any intersection events happen, and some options. And there's several different options that this constructor will accept. The first is the root element. The root is the element, like we said before, which is used to check for intersections of the target elements. And this option accepts any valid element on the page, though it is important to make sure that this element is an ancestor of the target element, or else the whole thing is going to fall apart. If you don't specify a root, which is totally fine, or if you pass in null as the value, the browser viewport becomes the root. But you can pass any valid element, so we'll query for an element with an ID of viewport and use that for the root. It also accepts a root margin argument. The root margin value is used to grow or shrink the size of the root element. You can pass values in a string, and it accepts a CSS-like format, so you can pass either a single value or a string of multiple values defining the margin on each side of the root element. In this case, we're just going to pass in 0 pixels and keep it to the standard element bounds. The final option is the threshold. And the threshold option specifies the minimum amount the target element must be intersecting the root in order for that callback function to fire. This accepts floating point values ranging from 0 to 1. So, for example, if you wanted the callback function to fire when your target is intersecting by 75%, you would put a threshold of 0.75. In our case, if we want to make sure that the element is completely on screen, we'll pass in a threshold of 1.0. It's important to note that if you want the callback function to fire at multiple points, you can also pass in an array of values, like this. So this would cause the callback function to fire every third of the way that it goes on the page. But we'll set that back to 1.0 for this example. Another thing that's important to understand are how the intersections themselves are calculated. So the intersection observer API considers everything to be a rectangle for the sake of this calculation. These rectangles are calculated to be the smallest they can possibly be while still containing all of the target content. Beyond the bounding boxes, you have to consider any adjustments to the bounding box of the root element based on the root margin values, and these values can pad or decrease the root size. It's also crucial to understand that unlike the traditional scroll events that you might be used to, Intersection Observer isn't pulling constantly for every single change in intersection. Instead, the callback function is only called when the provided threshold is reached, approximately. If multiple checks are required, you make sure you pass in multiple thresholds. The first demo project I want to take you through in this video is just a really simple way to see the Intersection Observer in action. It's just going to be a couple of boxes on screen. When you scroll down, they do a really simple animation when they come into the viewport. So I will be doing this demo in CodePen. I've got a little template, starter template that I've linked below. I also have a GitHub download. If you prefer to work locally, you can grab those starter files there, and they'll support all of the different little preprocessors and ES6 and stuff that I'm going to be using here. So I'll create a new pen from my template. We'll go ahead and first add the HTML that we need. So the markup itself is going to be really simple. I am using Pug here, which is just a templating language. So the first thing we're going to add is an intro slide. It's just going to have a little title. Then a little note to scroll down so that you can see the action. And then we're going to add another slide. This slide is going to contain a box. This box is going to spin when it comes on screen, so we'll make sure it's defined in that class there, along with the text element indicating the animation style. We'll add another slide with another box. This one's going to grow when it comes on screen. And then our final slide, also of course containing a box. We'll have a box that's going to move to the right. We'll also go ahead and add some simple styles to this markup. The first thing is that we want these slides to at least take up the full height of the viewport, and we want the content in them to be centered. So we'll just use a little flex box for that. We'll also set a minimum height of 100 viewport height. And we'll also go ahead and apply flex directional column to this intro slide so that the text flows vertically instead of horizontally. Next thing is to apply the styles to the boxes themselves. The boxes will also use Flexbox. I'm going to just scroll down here so that you can see. This is one of the boxes here. You can see it's centered. So we'll use Flex for these boxes as well to center that text content within them. fixed height and width. Add some font styles. And last, we'll give them a background color, as well as a transition on the transform value. That way the animation will happen over the course of a second instead of being instantaneous on scroll. And the last thing that we need to do is add the actual animation that will happen when the targets come on screen. So when the targets come on screen, we'll be applying a box visible class to them, and that's what will trigger the animation. So the spinning box is going to have a transform rotating 1080. The growing box will have a transform scaling up to 150%. And the moving box will just do a simple translate right X and move to the right 50 pixels. Alright. Obviously nothing is happening on scroll yet because we haven't done the JavaScript portion of things, so that'll be our final step here. Keep this visible now. Yeah, so now all we need to do is go ahead and set up our intersection observer. And just like before, this is a pretty simple thing to do. So we'll create our observer. First thing we want to do is set up our options that'll be passed into the constructor. And for this demo, we want to keep the root element just the browser viewport area, which is this area here. We don't want to use a different element on the page or anything like that. We want these animations to happen when the elements come on screen. So we'll ignore the root. We'll keep the root margin standard at 0 pixels as well. The only thing we want to specify here is the threshold value, meaning that the elements need to be completely on screen before the animation takes place. And then we can go ahead and call the intersection observer constructor. We'll pass it a callback function, which we will define next. Well, shortly, because the next thing we want to do is actually target the elements. So in our case, all of these divs with the class of box are the items that we're going to be targeting. And we'll just map over these boxes. And for each box, we will tell the observer to observe, easy syntax, that box. And now, whenever that box comes on screen, the intersection observer will fire the callback function. Now, of course, we need to actually go ahead and define the scroll emissions function, so that's the last thing we'll do here. And these callback functions, they're passed two things. They're passed an array of entries, so anything that's impacted by the current intersection status, and then the observer itself in case you need to grab any information off of that. So once we're in here, we'll loop through the entries. And we only want to do the animation if the element is fully on screen. And intersection observer fires approximately at the right time, but we just want to verify that the threshold has actually been met by using the intersection ratio variable that comes through on that entry. So the first thing we'll do is check entries intersecting. And we also want to make sure that the entry intersection ratio equals 1. It can't go above 1, so we just want to make sure that it's reached that maximum value. If it is fully on screen, we'll go ahead and find the target within that entry and add the box visible class to it. If it's not fully on screen, we want to remove the box visible class because this intersection observer will also fire when elements leave the screen. Okay, and that's all there is to that. So if you scroll down now, these boxes should do their animation. Okay, and that's all there is to that. So if we scroll down here now, the boxes should be animated. And it looks like they're not. So probably I have a typo somewhere. So let's just check this callback function out again. Entries, observer, entries, it's intersecting. Not ration, it should be ratio. Let's try that. There we go. Growing. One additional issue to fix here. Alright, and now everything should work correctly. So we see our spin, grow, and that's not moving. This should be move right here. And that should be visible. Let's try that one more time. Scroll, spin, grow, move. And that's it for demo 1. Alright, for the second demo in this video, I want to go through creating a simple on-page navigation component which highlights the section that you're scrolling through. So you see these all the time on single-page websites where they have an About section and a Contact section and so on. And as you scroll down the page, the different sections of the menu highlight. An intersection observer is perfect for this. So we'll just use the same starter template and CodePen in this video. The same files on GitHub will also work if you prefer working locally. And all of this is linked in the description. So we'll start with some simple markup. We're going to add a nav component containing a list, and these will contain the different links. And we'll add an active class to this first one because we'll start in slide 1. Just a couple more. Alright, and then we actually need to go ahead and add the different slides of the website that will trigger the intersection observer events. So we'll just give these all section elements and make sure that you apply the ID that corresponds with the nav item. So it'll be in numerical order, pretty straightforward, and each slide will contain a P tag declaring which slide you're on, so as you scroll it's clear. And that way you can also make sure that the intersection observer is working correctly and everything is configured. Alright, the styles will also be pretty simple for this. The nav bar itself, we want to keep it always pinned to the top so that you can see what's highlighted. So we'll give it a fixed position and we'll set it up at the top. have it meet both the left and the right side. Give it a width of 100% and also specify a background color of white so that it stands out on each different slide. Within the nav, we need to give this unordered list some styles, so we'll just remove the bullet points. We also want to make it use Flexbox, so that way we can evenly space out the items within the navigation. So we'll give it a display of flex, center the items vertically, and then horizontally we'll put space around them. Set it to take up the full amount of space, but we also want to set a max width because right now those elements are pretty far apart, so we'll set a max width of 800 pixels and a height specifically of 50 pixels, and then we'll center it with the margin, make sure we remove any padding. List items are really simple. All we need to do here is add some padding to them. And then the links themselves, first give them a display of blocks so they can fully take up the space and have the appropriate highlighting. Give them a height of 40 pixels, some padding to the left and right. We don't need vertical padding because the height is taking care of that. We'll set the line height to match the height of the item. We'll remove the underline. Make sure they're all uppercase, just an aesthetic choice. Make them gray instead of blue. Give them a bold weight. Also add a border radius here, which will matter more for the highlighted one and for the hover effects. We also want to transition the background color changes over 0.3 seconds so that they kind of fade in instead of abruptly shifting. We'll add the hover/active styles. And we'll just go ahead and apply a background color. We're going to use RGBA because we want this to be kind of opaque. And we'll also apply this to the active box. Save, and now you can see this first one is highlighted here. If you hover over any of these, they also get that background color. We also need to apply some simple styles to the different slides. So each section, we're going to use Flexbox to center the items both vertically and horizontally, that paragraph that's within them. We'll also set a minimum height of 100 V8 to make sure that each section takes up at least the full height of the browser. For the paragraph tags, just go ahead and center the text. Make them white. Once we apply colors to the slides, that will make sense. Increase the font size a little bit, make it bold, and uppercase. Last thing we'll do is apply some colors to each of the slides. They'll each get a different background color so you can clearly see when the transition happens from slide to slide as we scroll. And I just grabbed a little palette off of Adobe Color Creative Cloud. They have little 5 palette color schemes that you can explore, and I just found one that I liked and grabbed it. Even though it's just a little demo, I always like to make it look as nice as I can. Now if we scroll down here, each slide has a different color. But of course, nothing is happening up here because we haven't yet set up our intersection observer. So we'll just give ourselves a little more room to work here. And like always, the first thing we need to do is go ahead and set up the observer options and call the constructor. We just want to keep the root to be the browser viewport. We don't want to mess with the margins, so all we need to do here is set a threshold. I'm going to set it for 45%, so when the slide is 45% of the way on screen, so somewhere around here, that's when the number up there is going to go ahead and change which one is highlighted. Once the options are set, you can create the observer itself by calling the constructor. Passing it a callback function, which we will come back to, as well as the options. Then we need to target each of these sections that we define in the markup over here. So we'll do a query selector all for each section element. And we'll loop over them. Tell the observer to observe the section. Now the observer is set up, but we still need to go ahead and declare whatever this change nav function is going to be. And we get the entries and the observer as part of this function. And then we need to loop over the entries. We need to do a couple of things here. We need to make sure that the element is intersecting at all, and we need to verify that the intersection ratio meets that threshold that we specified. That way we're not like toggling back and forth between the different slides really rapidly or anything weird like that. So we'll just use a simple if statement. So we made sure it's intersecting, and then we'll check that the intersection ratio is greater than or equal to 0.45. If it is, we'll remove the old active class from the element with it. So we'll just do a query selector for active. We need to get the ID of the section that's currently highlighted. So that's the entry target is the element itself. And we'll just get attribute. So the last thing we need to do is find the appropriate link up here and add the right class to it. So I'm just going to do another query selector. Use a little template string here. That way we can throw in our variable of ID. We still have this little hash before it. And then all we need to do is add active to the class list. Alright, now we can scroll down. You can see it change up here. So we'll wait for section 3. Very good. Right around the 45% mark, and you get a little variability here because, like we said before, intersection observer isn't firing and pulling constantly. It's just, you know, when it's approximately there, which is more than enough for most of these use cases. Alright, we're working all the way down. So The last thing that we want to do to really make this demo work is actually get these links to work when you click on them. So they actually go to the right section already because we did set up the href over there, but it's kind of weird that they just hop right to it instead of scrolling. You kind of lose the sense of where you are on the page. So I found this great little plugin called ZenScroll. And it's just a really simple little smooth scrolling plugin. What I like about it is that all you have to do to make it work, if you have the markup done correctly, like we do in this pen here, all you have to do to make the ZenScroll work is load it. And it's on CDN.js. So we'll just search for ZenScroll, grab this link here, and then CodePen makes it super easy to load external scripts. You just click on this little settings link, paste it in there, save and close, and then we'll click on that, and the scrolling works right away. So that's why I like that one. You can also manually implement it and have a lot more granular control over it, but for this purpose, this is great. And the last thing that we need to talk about is the polyfill. So like I said earlier, Safari doesn't yet support the Intersection Observer API, which is obviously a big limitation. And while modern browsers support it, older browsers don't always. So you need to make sure that if you need to support those older browsers and Safari for the time being, that you're loading the polyfill. And there's an official polyfill available on the W3C GitHub. So you can look at the code, you can see the tests, you can understand how it's being implemented, and then you can manually load it if you want to, but I find that the easiest way to do this is to use a tool called polyfill.io. And here you just load the script and you can specify exactly which features you're using, and then it does all the work of loading only what each particular browser needs. So you're not loading a bunch of polyfills just for the sake of having them. It only loads it if the browser needs it. So Chrome won't load it, but Safari will. So I'll grab the link. And same deal, if you go over to your CodePen, click on the settings, and you can paste in the link there, save and close, and then the whole thing will work in Safari. As you can see, the Intersection Observer API is pretty simple to use and it works right out of the box. Even though the polyfill is still required for Safari, as browser implementation continues to progress, this API is going to be a great thing for improving front-end performance. Now, this video only covered a very basic implementation, but my upcoming videos are going to dive deeper into topics like performance and animation. These videos will cover topics like lazy loading, integrating with GreenSock, and the new performance concerns specifically when it comes to using Intersection Observer. If you want to be notified when they come out, make sure you subscribe below or click the link in my description to head over to my website and sign up for my newsletter. See you in the next video.